Computers have been applied to a number of different areas of our life, from controlling nuclear power plants to providing video games for mobile phones. Because of this great diversity in computer use, programming languages with very different goals have been developed. In the next discussion, we will discuss a few of the areas of computer applications and their associated languages. That we will discuss is the domain of scientific applications. The first digital computers, which appeared in the late 1940s and early 1950s, were invented and used for scientific applications. Typically, the scientific application at that time used relatively simple data structures, but required large numbers of floating point arithmetic computations. The most common data structures were arrays and matrices. The most common control structures were counting loops and selections. The early high-level programming languages invented for scientific applications were designed to provide for those needs. Their competition was assembly language, so efficiency was a primary concern. The first language for scientific applications, as we all know, was Fortran. Now, ALGOL 60 and most of its descendants were also invented around this time, although they were designed and used for other related areas as well. For some scientific applications where efficiency is the primary concern, such as those that were common in the 1950s and 60s, no subsequent language today is significantly better than Fortran, which explains why Fortran is still used. The next domain for programming languages that we will discuss will be business applications. The use of computers for business applications began in the early 1950s. Special purpose computers were developed, and as you would expect, also special purpose languages. The first successful high-level language for business was COBOL. Its initial version appeared around 1960, and it's still very commonly used for these types of applications. These applications were characterized, and still are, by facilities for producing elaborate displays, elaborate reports, precise ways of describing and storing decimal numbers and character data, and the ability to specify arithmetic operations. However, there have been quite a few developments in business application languages lately. The environment for business applications is changing to e-commerce. This e-commerce environment is characterized by industry giants like eBay and are used via apps and websites that support purchasing and conducting business on the web. Now, the languages that support these more recent business applications will be discussed at some length in this course, and we'll say very little about COBOL. Artificial intelligence is a very important programming domain. It is a broad area of application development characterized by the use of symbolic processing rather than numeric computations. Symbolic computation means that symbols consisting of names rather than numbers are manipulated. Also, symbolic processing or symbolic computing is most conveniently done with linked lists of data rather than arrays. This kind of programming sometimes requires more flexibility than other programming domains. For example, in some AI applications, the ability to create and execute code segments during runtime is very convenient. We'll see this facility illustrated as we study Lisp later. Now, Lisp was the first widely used programming language developed for AI applications, and it's called a functional language. It emerged around 1959. Most AI applications developed prior to 1990 were written in Lisp or one of its relatives. But during the early 1970s, an alternative approach to some of these applications appeared. A subsequent language called Prolog was used to support this area of programming called logic programming. More recently, though, some applications have been written in systems languages like C. Now we'll take a very close look at Prolog and Lisp later in the course. The next area for programming languages is the domain of systems programming. The operating system and the programming support tools of a computer system are commonly known as its system software. Systems software is used almost continually, and so it must be efficient. Furthermore, it must have low-level features that allow the software interfaces to external devices to be written. In the 1960s and 1970s, some computer manufacturers, such as IBM Digital and Burroughs, now Unisys, developed special machine-oriented high-level languages for system software for their machines. For IBM mainframe computers, the language was PLS, a dialect of PL1. For digital, it was Bliss, a language at a level just above assembly language. For Burroughs, it was extended Algol. However, most system software is now written in more general programming languages, such as C and C++. In fact, the Unix operating system is written almost entirely in C, which has made it relatively easy to port to different machines. Some of the characteristics of C make it a good choice for systems programming. It is low level, execution efficient, and does not burden the user with many safety restrictions. Systems programmers are often excellent programmers who believe they do not need such restrictions. But some non-systems programmers, however, feel C is much too dangerous to be used on large, important computer systems. The last area of programming language domains is web software. The World Wide Web is supported by an eclectic collection of languages ranging from markup languages like HTML, which is not a programming language, to general purpose programming languages like Java. But because of the pervasive nature and need for dynamic web content, some computation capability is often included in the technology of content presentation. Let me explain a little bit of what I mean. This functionality can be provided by embedding programming code in an HTML document. Such code is often in the form of a scripting language like JavaScript or PHP. There is also some markup languages that have been extended to include constructs that control document processing. This topic will be discussed later in the course. The picture I show below was included because, similar to system software, web software is used by many people and must be very efficient. And when it does not work properly, bad things can happen.